All right, hey there guys. Today we're going to look at a point slope form. So everything we've seen this far has actually been slope intercept form. So we're going to go to point slope form, which is a little bit different, and may like this because it is pretty user friendly. So this here is point slope form. The y minus y1 equals m times x minus x1. Of course, the x and x1 are in parentheses. So I'm going to ask you to go ahead and write this visual down. If you want to color code it, by all means, please do. So in the past, when we were asked to write an equation with a point and a slope, we had to go to slope intercept form. Well, the good thing is we can actually use point slope form in the long run to help us out here. So let's see what we got. So we have y minus y1 equals m times x minus x1. So this is your x and y, and of course your m. So really all we're going to do is put these values where they belong. So y minus 6, because it's a minus, so then equals our slope, which would be negative 1/3. And then we have x minus a negative 3. So in this case, we're going to rewrite that because we don't want that double negative there. So this would be x plus 3. So as you can see, whatever x was, it became opposite. Same with y, really, because y was a positive 6 in that coordinate, and it became a negative 6 over here. So then this equation is point slope form of a point negative 3/6 and a slope of negative 1/3. So what we're going to do now is actually graph this. So slope, which was y minus 6, already forgot, plus can use, which is negative 3/6 and the negative 1/3. So I'm going to graph negative 3/6. So negative 3/6 is here. And I have a slope of negative 1/3. So I'm going to go up 1, left 3. And down 1 this way, and so on and so forth. So this shows you what our line would look like. So you just graph your x and y, and then from there use your slope. Remember, your slope is rise over run. And you can grab that information from your equation. 3. It's the point. So the next thing we're going to do is actually change that original equation. Equals negative 1/3 times x. And we're going to change it to slope intercept form. So the first thing we're actually going to do is distribute to get rid of those parentheses. So y minus 6 equals negative 1/3 x minus 1, because 1/3 of 3 is 1. Then I'm going to add 6 on both sides to get y by itself. So y equals negative 1/3 x plus 5. So this gets us exactly where we need to be. And of course, this is the y equals mx plus b format. So we went from point slope form to slope intercept form. Now we're going to do the same thing, but with 2 points. So we're going to write that equation, y minus y1 equals m times x minus x1. But we have 2 points. So you can use either one and it'll work out for you. I'm going to use the second one just because it's positive. But first, I actually need to find my slope. So I have negative 2, negative 4, and 1, 5. So my change in y is a plus 9. While my change in x is a plus 3. So my slope would be 9 over 3, or just 3. So when I go to write my equation, this is the x, this is the y. So I have y minus 5 equals 3 times x minus 1. Okay. We're going to graph this one, I believe. So we're going to take, so we have negative 2, negative 4, and 1, 5, our slope. So our slope is 3. So we have y minus 5 equals 3 times point, or both points, doesn't matter. So -2, -4 is right here. And then 5 is here. So we're going to go, remember, it's 3/1 for rise over run. So I'm going to go up 3, 1, 2, 3 over 1. There we go. Up 3, 1, 2, 3 over 1. Up 2, there it goes. So it actually lines up for us. So we did do that correctly. And of course, you can always use Desmos to check your graphing. X minus 1, y minus 5 equals 3 times x minus 1. So we're actually going to multiply by getting rid of the parentheses in order to get it into this y equals mx plus b, right? So y minus 5 equals 3x minus 3. Now I'm going to add 5 on both sides. So y equals 3x plus 2. That one came out nice and pretty for us. All right, here's another one. This is where we have some real world situation. It says a train travels at a rate of 70 miles per hour. There's that per that we talk about. 2 hours after leaving the station, it was 210 miles from its original location. So in this case, we have two things that we're comparing, miles and hours. So hours will be the x, of course, because time is always x, and then miles will be the distance. So that means if I have a coordinate, my coordinate would be 2 and then 210, right? Well, 70 would be our slope because that is a unit rate or a rate at which something is happening. So when I write my equation, I have y minus 210 equals 70 times x minus 2. So this equation would be in point-slope form. We can also take it to slope-intercept form if we needed to, but we'll leave it in point-slope form. All right, so now we're going to write an equation in standard form of a line that passes through these, the given point and has this slope. Of course, we have to find the slope. So let's go ahead and start by finding our slope. Ooh, it's a minus 5. So our slope would be 10 over negative 5, which would be a negative 2. So now that I have a slope of negative 2, we can pick either point. Let's do it in both. So when I write my equation, I have y. So we have x and y here and x and y here. You got to use them separately, of course. So we would have y minus 2 equals negative 2 times x minus 7 would be one of the versions. Or we can have y minus 12 equals negative 2 times x minus 2. I'm going to show you that we end up with the same slope-intercept form. So if we distribute, we end up with y equals negative 2x plus 16. If I do the same thing over here, I end up with y equals negative 2x plus 16. So it doesn't matter which point you use, but if we're writing equations in point-slope form, this is where we are. That's the thing we have here. Oh, it's the same. Let's go ahead and try it on your own, and then we'll check it in class.